In the last video, we saw that my biological age, when using Dr. Morgan Levine's biological age calculator, PhenoAge, was 19 and a half years younger than my chronological. So what may be contributing to these data? So let's start off with supplements. And if you're familiar with the channel, the first two shouldn't be a surprise. So I was diagnosed with hypothyroidism in my mid-20s, so I've been taking prescription levothyroxine, 137.5 micrograms per day, every day since then. And then for about 8 to 9 months, a year, as I live in Boston, northeast latitude, I supplement with vitamin D, relatively low dose, 1,000 IUs per day. And note that that was for 49 of the 49 days for every day that corresponded to this blood test. So what is that 49-day period? Well, we can see that it was from January 15th, that's immediately after test number 1 in 2024, and that lasts until March 3rd, which is the day before test number 2. So that's a 49-day period from one test to the next. All right, 2 other supplements, Methyl B12, 1,000 micrograms per day, but I didn't use it every day of the 49 days, only 30 of the 49 days, as I'm still playing around with the dose to see if it actually does anything in terms of homocysteine. And then I also supplemented with nicotinic acid, 50 to 60 milligrams per day, but that too, it wasn't in the approach every day. It was only in the approach for 18 of the 49 days as I was trying various experiments, including fenugreek seeds, chickpeas, and other ways to increase NAD, potentially increase NAD, without nicotinic acid. And that's it. No other purported geroprotectors or senolytics, which brings us to diet. More specifically, what diet composition corresponds to test number 2 in 2024? And that's what we'll see here. And again, this is the 49-day test average. And for those who don't know, I weigh all my food, I log that data into Cronometer, and then I manually record that into a spreadsheet. I take the average dietary intake for that 49-day period, I line it up with blood test data, and because I have almost 50 blood tests going back to 2015, I can look at correlations and then follow the correlations with the goal of optimizing biomarkers. So in terms of the list, the full list is shown here. We can see that I ate 56 different foods during the 49-day period that corresponded to this test. In terms of the list, it's ranked in grams from highest to lowest, with the exception of green tea, which is in ounces, and I use organic loose leaf green tea sourced from Japan. If you want to use what I use, there'll be a discount link in the video's description. All right, so were there any experiments for this test? And fair warning, I should say, buckle in. We're going to take a deep dive on all of the different things that I changed that may have played a role in further reducing my biological age using Levine's test to 19 and a half years. I put timestamps in the pinned comment for those who may be interested in sifting through the video rather than watching it from start to finish. All right, so the first one I want to focus on is garlic. And garlic at 2.6, an average of 2.6 grams per day, may not seem like much, but that's approximately 2x higher than the average for the 49-day period that corresponded to the first test in 2024, 1.4 grams per day. Both of those intakes are higher than my average since 2015, which is only 0.5 grams per day. So why did I raise garlic intake? So garlic is significantly correlated with a younger Horvath epigenetic age. And actually, I should say it's one of only 2 foods or nutrients that has a p-value less than 0.05 for its correlation with Horvath epigenetic age. And if you're interested in full correlation lists with biomarkers, that's on the correlations tier on Patreon. So in terms of the correlation between Horvath epigenetic age versus garlic intake, we can see that here over 12 tests so far for Horvath. That's what we've got on the y-axis, Horvath epigenetic age, plotted against the average daily garlic intake. And again, this is the average intake from one day to the next. In this case, for this test, it was a 49-day average. In terms of the correlation, we can see that it's a significant inverse correlation for average daily garlic intake with Horvath epigenetic age. In other words, we can see that the correlation coefficient, the lowercase r, is negative 0.59, and that p-value is less than 0.05 as the measure of statistical significance. So when considering this correlation, what happens if I go higher? If this correlation is really somehow causatively involved, and again, I don't know that it's causation. It's only a correlation. The only way to test causation is by actually increasing or decreasing level of this food. So that's what I did. I increased it to 2.6 grams per day, and we'll see. The data's not yet in. Results are expected at the end of March. If I was able to reduce Horvath epigenetic age. If I was, this correlation will strengthen. If I wasn't, then this correlation will weaken, and whatever pops up as the strongest correlation or group of correlations, I'll try to follow all of them with the goal of reducing my Horvath epigenetic age. All right, so back to the which experiments that I do for this test. So I also added alfalfa sprouts into the approach. So why? Alfalfa sprouts are a good source of trigonelline, 181 micrograms per gram of alfalfa sprouts, and trigonelline increases NAD, at least in mice. I'm still not convinced, or I don't yet have any data that it increases NAD, at least in me, after a few tests in testing NAD. So in terms of the amount of alfalfa sprouts, 25 grams per day for an average 49-day period may not seem like a lot. But for 8 days prior to this test on March 4th, I averaged 132 grams of alfalfa sprouts per day. And I should mention, it got expensive at $5 for 100 grams to buy them from the grocery store. So I'm now growing my own sprouts and sprouting once every about 4 days, yielding about 700 grams at a far cheaper cost. So the alfalfa sprouts for those 8 days yielded 24 milligrams of trigonelline per day. Now, I also added other foods into the diet during this period with the goal of increasing trigonelline, including green peas, snow pea shoots, fenugreek seeds, which made a small appearance for about 10 or 11 days with the goal of increasing trigonelline to try to increase NAD. And in sum, these foods provided 48 milligrams of trigonelline per day. Now, to put it into perspective, remember, just 60 milligrams of nicotinic acid raised my NAD to 39 micromolar, which is higher than my baseline, which is usually less than 26. So that 48 milligrams of trigonelline may not seem like much, but it could impact NAD. So when compared with the first test in 2024, trigonelline content, average daily trigonelline content was only 27 milligrams per day. So I was able to increase it for this test. And then the big question is, was NAD increased or was it impacted at all? And that video will be in one of the next 2 videos. I haven't decided if it's next or the one after that. All right, so in order to get these calories into the diet, in order to stay slightly below my normal calorie intake, I had to reduce other foods. And those foods were barley and oats. And if you're familiar with the channel and you're familiar with these diet composition videos that correspond to blood tests, barley and oats are generally around 30 grams each in my diet. So you can see that I've reduced them both to 5 grams each in order to get, again, the other stuff that has calories into the diet without going above my maintenance calorie intake and actually trying to stay a little bit below so I can get to my leanest. All right, so I also try to increase methyl donors with the goal of reducing homocysteine. Now, when it comes to methyl donors, most people think about trimethylglycine or betaine. Now, the most concentrated source of TMG in my diet comes from beets, which contains 750 micrograms of TMG per gram. And I'll put the link to the studies that have betaine content in various foods in the video's description. So for this test, beets average was about 257 grams per day. And that's up from 232 grams per day for test number 1. So a 25 gram increase. Now that might not seem like much, but for 11 days before this test, I increased beets to 302 grams per day. So that increase in beets by about 70 grams per day yielded an additional 53 milligrams of TMG per day. Now, I should mention, I tried to, for those who don't already know, I tried to use diet to impact the biomarkers first. I've tried up to 4 grams of TMG per day in the past. It didn't have an impact on homocysteine at all. So I'm not convinced that supplementation will be the way to go, but I'm also not convinced that diet will be the way to go in terms of reducing homocysteine, as I've not been very successful to this point. So in terms of TMG, quinoa is also a great source as it contains 611 micrograms per gram. So with that in mind, quinoa made an appearance in the diet. We can see it there, but not a big appearance. You can see that's only an average of 2.3 grams per day. And it wasn't until I realized that quinoa is a rich source of oxalates, and I'm trying to reduce oxalates, or if I'm going to add foods into the approach and they have a significant amount of oxalates, hopefully they have an even larger amount of calcium. And that too is on the video to-do list to compare oxalate absorption in the presence of calcium. Now, TMG isn't the only place we can get methyl donors. And in an earlier video, I covered proline betaine, which has methyl groups attached to its nitrogen atom, just like TMG has methyl groups attached to glycine's nitrogen atom. So in terms of proline betaine, in the last video that corresponded to blood test number 1 in 2024, we saw that I added oranges into the approach. So I didn't increase them for this test, but for those who may have missed it, I reduced strawberry intake in order to get the oranges into the approach. Now, alfalfa sprouts are also a good source of proline betaine, especially when considering that I ate 132 grams per day for, the about week or so before the test. Alfalfa sprouts have 70 micrograms per gram, so that also contributed a small but a decent amount of proline betaine to the methyl donor pool. But then also tryptophan betaine. So same story, the nitrogen atom of the amino acid tryptophan has methyl groups attached to it that can potentially act as methyl donors to potentially reduce homocysteine. There are 3 main sources of tryptophan betaine, including chickpeas, peanuts, and lentils. So chickpeas were already in the approach, and I'm probably going to keep them in for at least a few more tests, as that's significantly correlated with lower creatinine. And that may be one reason why my creatinine over the past 2 tests has trended towards below average, which is good because creatinine increases during aging. I also increased peanut intake with the goal of getting more tryptophan betaine. We can see that I increased it by 14 grams per day. Peanuts, I'm going to keep them too relatively high going forward, as they are inversely correlated with the sum of the liver enzymes ALT and AST, which may be one reason why they moved in the right direction relative to their higher values for test number 1. Now, I also added lentils into the approach, but I finally realized that I'm not generally a fan of lentils in terms of their taste. So unfortunately, I took them out. And note that in terms of tryptophan betaine, they are the most concentrated source relative to chickpeas and peanuts, but yet I just can't do it. I mean, I've got to be able to include foods that I like in order to have them long-term in the approach rather than have foods for the nutritional content, and I just don't enjoy it. All right, so in terms of the sum of methylated amino acids, and that also includes trigonelline, it was 311 milligrams per day for this test. In comparison, for test number 1, it was 246 milligrams per day. So that's about a 25% increase in the methyl donor pool. So then the big question is, did I reduce homocysteine? And unfortunately not. For this test, on the same day of testing, it was 11 micromolar. And for comparison, for the previous 15 tests, my average homocysteine is 10.4 micromolar. So it actually went in the wrong direction despite a higher amount of potential methyl donors. How I'm going to reduce homocysteine going forward, that'll be a story for another day. Now, some other highlights that I changed for foods in the diet. Cocoa beans, cacao beans, I doubled their intake, so from 1.5 to 3 grams per day. And again, that might not seem like much, but we don't know the dose of foods or nutrients that may be needed to make a dent on biomarkers. In my data, cocoa beans are significantly correlated with lower MCV, so that may be one reason why MCV moved towards more youthful values for this test by increasing cocoa beans. And then I also increased vanilla bean intake from once a week to once every 3 days. And I did that because, as we'll see in an upcoming video, vanillin inhibits growth and can kill off an oral microbe known as Serratia marquescens, which has been dominant in my oral microbiome for many tests. So I haven't yet made that video about whether vanillin in a mouthwash could eliminate Serratia from my oral microbiome. But when considering that vanilla beans are a rich source of vanillin, I think it makes sense to not only have it in the mouthwash, but then also to have it ingested, and then my salivary glands can secrete it into my mouth and potentially reduce Serratia levels. And then I also added in sunflower seeds. So sunflower seeds made random appearances here and there over the past 8 or so years in the diet. But when considering that almonds are a rich source of vitamin E, so are sunflower seeds. But the difference is that almonds have relatively higher oxalates. And I don't think oxalates are a problem for me right now because my calcium intake is about double that. But I'm trying to limit my oxalate intake while keeping calcium levels relatively high with the goal of optimizing bone density during aging. All right, so the diet isn't perfectly clean. I do generally try to limit my cheat meals to no more than 2 per dietary period. So no more than 2 for the 49-day period that corresponded to this test. And in terms of what those cheat meals included, it shouldn't be a big surprise. I'm a big fan of Reese's peanut butter cups. So I make kind of a homemade version with melted chocolate with peanut butter. And I sweetened it this time instead of sugar or sweetened condensed milk with honey. Now, in terms of the calories that chocolate chips and honey, which are generally nutrient poor, contributed for this 49-day period, it's 0.9% of all calories. So the diet is 99.1% clean. All right, so this list is ranked in grams. What about foods in terms of calories, in terms of how they rank in the diet? And that's what we can see here. So note first that these data are generated by Cronometer, and if you want to track your own diet using Cronometer, there'll be a discount link in the video's description. So in terms of the food that contributed most to my calorie intake, my daily calorie intake, as it has been for many tests, it's sardines, basically the cornerstone of my diet. And in terms of the other 9 foods, 9 of the 10 foods that are on this list were also the same for test number 1 in 2024. Peanuts entered the list. Pistachios came out. I didn't reduce pistachio intake, but because I increased peanuts from test 1 to test 2, they now made the list. And I should note too that I'm not trying to blow up the diet with the goal of improving a couple of biomarkers here and there. Biological age using Levine's PhenoAge and Dunedin pace as another example are relatively youthful. So it's a matter of keeping the overall structure while making small changes where possible, while keeping the overall structure in terms of protein, total fat, and even the foods that I include. All right, so that brings us to macronutrients. What macronutrient corresponds to this test? So let's start off with calorie intake, which averaged 2076 per day. And if I know for those who are familiar with the channel, I've been saying that for test over test over test. But this is, again, my lowest average daily calorie intake since I started tracking diet in 2015. And my previous low was 2092. And for those who may not be familiar, I've been trying to get as lean as possible and making very small calorie cuts over a long period of time, which is why I've been saying for many tests, this is now my lowest calorie intake. And I may dedicate a whole video just to reducing body weight, being able to consistently reduce body weight with small calorie cuts over time, just to illustrate the process. Protein intake average was 97 grams per day, which is about 90% of total calories. Fat intake, we can see that here. I averaged 84 grams per day, which is slightly up, and we'll see why in a second. In terms of percentage of calories, it was 36% of total calories coming from fat. Now, note that saturated fat at 19.6 grams isn't much different from test number 1, which was about 19 grams per day. But for the past 3 weeks, for the 3 weeks prior to this test, my average saturated fat intake almost exclusively from coconut butter was 25 grams per day. And I did that because in my data, saturated fat is significantly correlated with higher LDL. And I'm not talking about crazy high, just trying to push it towards the higher end of my range, as that may be involved with a younger Dunedin pace, a younger epigenetic pace of aging. So to test that hypothesis, I raised my saturated fat intake for the 3 weeks prior to this test. But also, again, note, in terms of overall dietary structure, we can see that omega-3 and omega-6 are exactly where they were for test number 1. In fact, almost exactly where they've been for many tests going back, at least a year. And that goes back to this idea of not messing with the structure of things that may be core components of an overall mostly youthful biomarker profile. All right, next up, carb intake. And that's what we can see here. Total carbs at 274 grams per day. That seems like a lot, but note that net carbs equals total carbs minus fiber. Fiber average was 88 grams per day. So when subtracting that from total carbs, we get a net carbs of 187 grams per day. When multiplying that by 4 calories per gram, the diet consisted of 36% of calories from net carbs. And then also note that fiber contributes calories as soluble fiber. Within fiber, there's insoluble that's not fermented by gut bacteria. And then some of that, about 25%, an estimated 25% or so, can be fermented by gut bacteria into short-chain fatty acids. In other words, the fiber is converted into fat. So with that in mind, 185 calories coming from soluble fiber can be added to total fat. And in terms of a percentage, that's about 9% of total calories coming from fiber fermentation. So with that, we can see my net macros are about 45% fat, 36% net carbs, and about 19% protein. All right, now within sugar intake, I also track total fructose as the diet is rich in fruits and vegetables, which contain fructose. So in terms of total fructose for this test, it was about 61 grams per day. Note that fructose plus half of sucrose, as sucrose is half fructose, yields the total fructose amount. In terms of 61 grams being a lot, I know it seems like a lot, but that's once again close to my lowest fructose intake since 2015, which is 57.5 grams per day. And I've mentioned this in other videos, but I've had total fructose intakes as high as almost double this. So this is progress, albeit not perfection. All right, so what about micronutrients? What profile corresponds to this test. And I won't spend a lot of time on that, but first we've got vitamins. And note, as I've mentioned in other videos, full RDA coverage, but then many of these are purposefully much higher than the RDA as I'm following correlations with the biomarkers. In other words, for vitamin K, if it has a positive correlation with more biomarkers going in the right direction than wrong in terms of how they relate to aging and all-cause mortality risk, I want to have vitamin K towards the higher end of my range because it's positively correlated with more biomarkers going in the right direction than wrong. In contrast, things like beta-carotene actually have a net negative correlative score, so I don't aim for my highest intake since 2015, but somewhere below that. All right, and then last but not least, mineral intake. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. And before you go, we've got a whole bunch of discount links that you may be interested in, including discount links for epigenetic testing, oral microbiome composition, NAD quantification, at-home metabolomics, at-home blood testing with SciFox Health, which includes ApoB, but also now GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Dietary brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.